Okay, this is VCAA 2010, Exam 1, Question 3. So we've got the classic experiment here where we've got a mass hanging over pulley, pulling along another mass. And the key to this question, first of all, is that it's a frictionless surface. And since it's a frictionless surface, there's no retarding forces on this first mass. The string's attached over a frictionless pulley, and this particular mass here is free to fall. So there's a force of mg acting here. There are, of course, tension forces here and here, but we'll see in a minute why those aren't particularly important. One way to look at these this question is to consider the system. I'm just going to redraw this. So I've got mg, and we have tension there, and it's to talk about this whole system, and it's equivalent to this sort of diagram. Got our tensions. I'll just redraw that a bit neater. We've got our two objects. We've got a tension, and we have this external force, mg. So there is our system. We can make that even simpler by just thinking about the system as one object. There's our system. And it's being accelerated by a force mg. So when we describe the net force on the system, since it's accelerating, it's going to be equal to ma, according to Newton's second law. In this case, the only force on the system is mg. And that's equal to mass times acceleration. But here's the trick. It's not this m. It's the mass of the system. So I'm just going to write mass of system times a. Now mg is 0.1 times 10, but the mass of the system is 0.1 plus 0.4. It's the two masses. So our acceleration is actually going to be 1 divided by 0.5, which is 2 meters per second.